In this video, we're going to look at solving a differential equation via separation of variables. So, separation of variables with an initial condition. The way separation of variables works, so this is a 5 over here, is we need to get all the z's on one side and all the t's on the other, and we don't want dz to be in a denominator or dt. They have to be in a numerator. So that makes it pretty straightforward as to which one is going to go where. The dz is going to stay, which means this is 1 over z is going to stay over here. And we're going to cross multiply the dt. So what we have is 1 over z dz equals 5 dt. So now we'll just take the antiderivative of both sides. So on the left hand side we get ln of the absolute value of z equals 5t plus c. Now we're going to call this c1, and we'll see why in a second. And we only need a c on one side because what we've done is we've absorbed the constant that would come on this side into this side. Now to solve this, one way I like is to just make both sides exponents of e, because we'll have a property of logs that will allow us to simplify this side. E to the ln of z is just equal to z, and we don't have to worry about the absolute value now. And this is equal to e to the 5t plus c1 up in the exponent. But by properties of exponents, I could write that as e to the c1. Now what I'm going to do, e to the c1 is also just a constant. I'm going to absorb that into another constant. I'll call that one c. So c is going to be equal to e to the c1. So I have z equals c e to the 5t. And there is the general solution to my differential equation. It's a family of functions. Now we had an initial condition that z of 1 equals 5. That means when t equals 1, that's a t value, that z has to be 5. So this is kind of a function notation here. So we're going to plug those in and solve for c. So z has to be 5 when t equals 1, so that's e to the 5 times 1, or e to the 5th. So solving that for c by dividing by e to the 5th on both sides, we get not the prettiest c, but we're going to get c equals 5 over e to the 5th is our constant. Okay, now let's see how this looks in our solution. So we're going to take our solution and plug in our c. So we have z equals, our c was 5e to the 5th times e to the 5t. Now if we don't like the way that looks, we can, because we have base e's in here, we can actually simplify this a little bit, because this is 5e to the negative 5th e to the 5t. Alright, and now properties of exponents say we can combine those to be 5e, so their exponents will add to the 5t minus 5. So it's a little bit nicer looking function than 5 over e to the 5th e to the 5t. This is the unique solution to this differential equation given this initial condition.